Soil is sculpted, and seedlings take root thanks to the Bracke P11.A working its magic across rough terrain. The tracked excavator carries the P11.A head, ready to turn forest regrowth into a streamlined operation. Each planting mound is shaped, compacted, and a seedling is set exactly in its center. From the operator's cab, the control system adjusts depth, compaction, and planting mode with ease. Sensors constantly feed data to the control unit, ensuring every seed goes in at the right depth. When the P11.A head lowers, its bucket loosens or scarifies the soil, or skips scarification completely if the operator chooses direct planting. Then the machine compacts an inverted humus mound and plants the container seedling on top of mineral soil for optimal root access. The same machine handles ground preparation and planting, no need for extra passes. For stony or debris-filled ground, this flexibility lets foresters adapt on the fly. After placement, the system logs each plant's position, counts total seedlings planted, and records machine hours. Data helps operators track productivity and maintain planting standards across varied sites. Real-time monitoring lets operators detect mismatches immediately, a big bonus for ecological regeneration. Whether working fertile soil or rocky ground, the P11.A delivers consistent regeneration quality. The operator picks the planting spot for each individual plant, giving control over spacing and microsite conditions. Even challenging terrains get a fair shot at reforestation with this setup. Over a long day, the machine can plant hundreds of container plants, making large-scale reforestation feasible and efficient. Spanning dozens of meters across the field, the air seeder seen in the 2016 Zell's Planter video moves seed in a single pass, transforming vast farmland rapidly and efficiently. Central hoppers filled with seed, and optionally fertilizer, feed a pneumatic delivery system where a fan pushes seeds through tubes down to each furrow opener. They are designed to handle hundreds of kilograms of seed without frequent refilling, which keeps operations moving smoothly. Each tube is carefully calibrated to prevent blockages and maintain uniform distribution. Seed flow is metered volumetrically below the tank to ensure a consistent rate per acre. As the seeder is pulled by a tractor, opener blades slice shallow trenches in soil, then compressed air jets deliver seeds into those furrows. Press wheels follow, gently pressing seeds into soil to guarantee solid seed-to-soil contact. The result is even spacing and uniform depth, ideal for grains, legumes, and cover crops. Operators monitor seed density and can make small adjustments on the fly to maintain precise planting rates. Seeing seeds drop evenly across dozens of rows makes the scale of planting here hit home. This method works especially well on large farms. The wide working width and airstream distribution cover more ground faster than traditional drills. After seeding, the field shows neat rows ready for germination with minimal soil disturbance. In short, this air seeder system combines speed, uniformity, and ease of operation, everything a modern, large-scale farm needs. That many seeds landing so evenly almost looks like organized rainfall. Thousands of meters of Netafim underground drip lines keep hay fields fed with steady moisture. The Netafim system feeds each row with controlled moisture, keeping roots hydrated without wasting water. That hidden network delivering moisture so evenly feels surprisingly efficient. Tractors move across the field laying hay in long windrows, and the soil stays firm thanks to the subterranean lines remaining untouched. The way the hay lifts cleanly almost reminds you of unrolling a carpet. Balers sweep through next, compressing and tying each block. With water supplied precisely below ground, grass growth stays uniform, boosting bale consistency. Seeing the rows so even hits unexpectedly strong. Farms using this setup achieve steady output with lower water use. Hundreds of tons of sugar beets move through a full cycle each day, with the Mouse 6, Tiger 6S, and Panther 2S working across wide fields. Its layout keeps movement controlled so each beet moves toward the cleaning modules, and that pull feels like raw traction turning field chaos into neat order. As the conveyor lifts the crop upward, dirt is stripped away by rotating rollers that leave clean beets for transport. The Tiger 6S then advances to lift beets from deep soil using its multi-row lifting unit. The lowered opener guides the lifting shares beneath the roots, and its torque gives a firm upward draw. That lift looks stronger than you'd expect from a machine gliding across soft soil, adding confidence as roots pass through the turbine system. The cleaned flow gathers in the bunker, and the transfer boom swings to load trailers beside it. Feels like the machine barely pauses even when the bunker fills. This steadiness keeps operators moving confidently across long rows during peak harvest hours. The Panther 2S follows a similar path, but focuses on swift coverage. Its front module settles over the next rows, letting the lifting shares rise through the soil profile. The crop enters the cleaning section where rollers remove soil clusters before sending the beets into its bunker. That steady surge almost feels like the machine refuses to waste momentum. When the boom extends for unloading, the timing between operator and machine keeps the stream consistent. Across the field, these three form a coordinated setup: Mauve's 6 handling loading, Tiger 6S extracting clean roots, and Panther 2S pushing high throughput. You'd never think such force and finesse could run this smoothly across uneven ground, and the pace can catch you off guard. Their combined output turns wide acreage into manageable work for any harvest crew. A mechanical harvester rolls down the pepper rows, its arms sweeping through leaves as it seeks ripe bell peppers ready to pick. A pneumatic grabber closes around the pepper, and a cutter severs the stem. The fruit drops gently into a collection bin mounted on the machine. That grab and cut move makes harvesting look almost automatic. With each pass, dozens of peppers are harvested in a fraction of the time manual picking would take. The operator adjusts ground speed to match fruit density so the picker doesn't overload the intake system. Once collected, peppers are transferred via conveyor or shuttle to crates for sorting. This method drastically reduces physical labor and speeds up harvest cycles while maintaining consistent quality. Sensors on the intake help the machine reject leaves or debris before they reach the sorting stage. Seeing dozens of peppers collected so quickly kind of feels like pressing fast forward on a harvest season. The harvester handles fruit gently to avoid bruising, and the design minimizes damage to plants, crucial for yield across multiple harvests. The cutter heads use a low-torque mechanism to keep stem cuts clean without stressing the fruit. After sorting, peppers move to packing or cooling, ready for market without long delays. Some models even allow height tweaks on the fly, so the pickup system stays aligned with uneven soil. Using mechanical harvesters for bell peppers shows how technology can scale agriculture without sacrificing produce quality, and gives farms the ability to respond faster to demand. The semi-automatic picking bridge at top machine bow allows up to 300% faster harvest per worker, reaching rows that were previously time-consuming. It revolutionizes the fresh market, combining human dexterity with machine support to dramatically increase output. The bridge allows workers to reach multiple rows without bending, reducing fatigue while speeding up harvest. Mushrooms are gently lifted from trays, guided by the bridge system that aligns precisely above the crop. The integrated weighing system automatically measures each harvest, ensuring accurate tracking for market demands. Consistency is impressive. Every mushroom is weighed immediately, minimizing errors and saving time. Water drainage channels built into the system prevent excess moisture from pooling on the trays, keeping mushrooms fresh and undamaged. Workers move along the bridge, collecting mushrooms at a pace up to 3 times faster than manual methods. The bridge's adjustable height accommodates different tray sizes, making it versatile across production lines. After picking, mushrooms are quickly funneled into collection bins, ready for transport or further processing. Real-time monitoring of the semi-automatic bridge ensures smooth operation and helps identify bottlenecks instantly. Even small adjustments to the conveyor speed are automated, keeping the harvest flowing seamlessly. Top Machine Bow's bridge merges efficiency, ergonomics, and precision to enhance fresh mushroom production for market-ready quality. The planting robot moves gently, yet sets each lettuce firmly, keeping the rows stable. The mobile gully system carries seedlings forward, while the robot ensures proper planting depth. That coordination looks sharper than you'd expect for such compact machinery. With the mobile gully system, HortiPlan can handle thousands of seedlings per hour, streamlining lettuce production in Belgium. Each plant finds its precise spot, maximizing growth potential and space efficiency. The robot handles thousands of seedlings per hour, reducing manual labor drastically while keeping the young plants safe from damage. Water and nutrient delivery through the system ensures consistent growth, and all excess water is recaptured for reuse. Seeing automation handle delicate seedlings, this efficiently really catches your attention. After planting, the trays move along the MGS installation, ready for controlled climate care and subsequent growth stages. Delicate lettuce seedlings are planted at high speed by robots without damage, maximizing growth and minimizing labor. The mobile gully system, MGS, developed by HortiPlan, sets the stage, holding over 200,000 seedlings with controlled spacing at nearly 15 heads of lettuce per square meter. Seeing that robot place each plant with steady speed is satisfying. It moves like a small army on the go. After a few days, the plant robot transfers each lettuce seedling into the gully, advancing at a pace of over 10,000 plants per hour. The gully holds 12 to 46 heads per section, optimizing growth before harvest. Harvest runs 6 days a week, yielding roughly 500 lettuce heads daily. A second robot manages full bale stacking and rapid return of empty trays, keeping operations continuous. Substrate is compressed soil with water and nutrients, and all water is collected, purified, and reused. The lettuce stays cool until loaded into refrigerated trucks heading directly to supermarket distribution centers. Controlled climate minimizes crop protection use, prolonging freshness and preserving flavor. You wouldn't guess such a system can maintain speed and care simultaneously. Jute fibers at the processing plant are treated to maximize strength and uniformity before spinning. The raw fibers are first weighed and sorted to remove impurities, which is crucial for high-quality yarn. Each batch is carefully inspected to ensure fiber strength and uniformity. Large spreaders loosen the fibers while softeners treat them for pliability, preparing the material for the next step. Softening helps prevent breakage during carding, keeping fibers aligned properly. Carding machines align the fibers into smooth, continuous strands, removing short or weak fibers. This step increases the overall durability of the final jute fabric.
A me mi piacciono tutti i giovani e sposati. Puro. Capella amore pazzo. Se li ha saputi prima m'era rimasto signorina. Capella amore pazzo, capella amore pazzo.
Drawing frames then combine multiple slivers into uniform threads, increasing tensile strength and consistency. The drawing process ensures that each thread can withstand mechanical stress during weaving. Spinning machines twist the threads into yarn, each rotation precise and steady, producing fine yet durable jute yarn. Yarn tension is continuously monitored to avoid weak spots or uneven thickness. Winding machines coil the spun yarn onto bobbins, ready for the final weaving or packaging steps. Operators confirm that bobbins are filled evenly to maintain loom efficiency. Beaming frames prepare the yarn for loom operations, ensuring the correct tension and alignment across multiple threads. Proper beaming prevents weaving errors and maintains uniform fabric density. Finally, finishing processes treat the jute fabric to enhance texture, durability, and appearance. Finishing can involve brushing, washing, or chemical treatments to increase softness and longevity. The journey from coarse fiber to soft, strong jute fabric shows how traditional techniques and modern machinery can coexist. Workers monitor each stage, adjusting machines as necessary to maintain consistent output. The facility maximizes efficiency while keeping quality high, with data from previous runs guiding adjustments to tension, speed, and moisture levels. Continuous feedback loops between machines and operators reduce waste and improve overall productivity.
Non ho capito questo ragionamento che avete fatto. Se chiude la metà da attaccare.
Thousands of cashew nuts are cooked, shelled, peeled, and packed every hour by Oscar Cashew Tech's turnkey plant. From the moment raw cashew nuts enter the facility, the automated grading system separates them by size and quality. The grading system can detect subtle differences in shell thickness, ensuring only the best nuts proceed. That sorting precision makes it clear why yield is consistently high, and it almost feels like the machines can sense which nuts deserve priority. The nuts then move into the steam cooking system, where controlled heat loosens shells to prepare for extraction. Seeing them enter the cooker and knowing they'll emerge ready for shelling is satisfying for process enthusiasts. Steam is circulated evenly around every batch, making sure no nut is undercooked or overcooked. Following cooking, the fully automated shelling and kernel separation system takes over. The machine scoops nuts, cracks the shells, and separates kernels with minimal breakage. That pull and crack of each nut looks like an orchestrated move that balances speed and care. Even at high speed, the shelling system keeps breakage below 5%, which is impressive for such large volumes. Next, the cashew kernels enter the drying system, carefully controlled to ensure uniform moisture. Once dry, the humidification system restores optimal moisture levels to preserve texture and flavor. Sensors constantly monitor moisture levels, adjusting airflow automatically to maintain quality. The drying system's airflow pattern is optimized to prevent uneven drying that could affect shelf life. It's striking how such an automated flow maintains the delicate balance of dryness and softness for top-quality kernels. Peeling is fully automated, removing the thin testa from each kernel efficiently. After peeling, kernels proceed to grading and color sorting. State-of-the-art machines separate nuts by size and color, ensuring only premium-grade kernels reach the final packing stage. That sorting line almost feels like a miniature army selecting the best candidates for market. The color sorting system can identify subtle discolorations, ensuring a consistent appearance in every batch. The packing line is entirely automated, sealing kernels into bags or cartons while monitoring weight and quality. The plant also accommodates value-added products, expanding production versatility. Real-time monitoring at every stage guarantees consistency, and integrated automation reduces manual labor while increasing throughput. The coordination across machines makes the entire operation feel like a living, synchronized system. Even the conveyors are programmed to adjust speed automatically to match upstream and downstream processes. Environmental consciousness is built into the design. Water recycling, energy-efficient steam generation, and minimal waste help reduce the ecological footprint. From grading to final packing, the turnkey setup provides operators with a seamless experience that merges speed, precision, and quality assurance. You might not expect such complex automation to operate so smoothly. Energy use is continuously monitored, ensuring steam and electricity are optimized for every batch. Whether processing for large-scale commercial supply or specialty markets, this plant ensures maximum yield, high-quality kernels, and consistent output. The combination of steam cooking, automated shelling, precise drying, peeling, and advanced grading produces cashew kernels ready for retail or industrial use. Each system integrates tightly, supporting continuous operation with minimal downtime. That level of integration feels like the entire factory is performing a carefully timed ballet, but with raw nuts. The plant's modular design allows quick maintenance and minimal disruption if any unit requires attention. This fully automatic plant elevates cashew processing to a level of efficiency and consistency rarely seen in the industry.